from x equals 0 to x equals 8. And we're going to rotate around the x-axis. Okay. Graph first. X to the 2/3. Just the part from 0 to 8, so almost like a sideways parabola for that chunk of it. So we're chopping it off at 8, so I drop that perpendicular there. 8. Where's my 8? Okay. So I could draw my rectangles vertical here and have a cylinder without a problem, because I'm going around the x-axis. I could easily draw them perpendicular and be fine all the way through, but we want to practice the shell technique today. So because I'm going around the x-axis, I have to draw my rectangles parallel to the x-axis to create a shell. Tomorrow we may do some problems both ways so that they do come out the same, but so parallel. All right, so because my width here is a dy, I want to see y's in my integral, and I want y boundaries. So on the y-axis here. So my lowest point is here at 0. My highest point is here, and I want the corresponding y value. So I'm going to find that first. Well, what I know about this point is that the x value is 8. I need to know what the y value is. So I'll put 8 in for the x. So y is 8 to the 2/3. 8 raised to the 2/3 is 4. So this point is at 4. So we're using the shell formula. We're going 0 to 4. Shell formula is 2 pi r h w. 2 pi carries. Radius, remember, is the distance from your axis of revolution to each rectangle. I'm going around the x-axis. This distance to each rectangle is a vertical distance. In the coordinate plane, we call that vertical distance a y distance. So here my radius is y. So my r is a y. The height is the height of my rectangle. That's going to be right minus left. Well, every rectangle, the right edge is at 8, minus the left edge is the function. The function is y equals x to the 2/3. Problem here, I've got x here and I don't want to see x here. I need to see all y's. So I'm going to rearrange this equation to get it in terms of y. So I'm going to do that off to the side. So here I've got y equals x to the 2/3. To solve this for x, I need to raise to the reciprocal power here to the 3/2. So I've got to raise this to the 3/2. So I get x equals y to the 3/2. So instead of x to the 2/3, I'm going to put y to the 3/2. So there's my height in y's. So in parentheses, 8 minus y to the 3/2. And then the width, I already started with it, dy. Okay, very easy process if you know that r is either the x or the y distance, and the height is what it's been all the way through, right minus left or top minus bottom. Okay, pull the 2 pi out in front. Not ready to integrate until I distribute. I'll have 8y minus y to the 5/2 dy. Now integrating, 2 pi. Each term add 1 to the exponent. That's going to give me 8y squared times a half minus y to the, it'll turn into 7 halves, times 2 sevenths, from 0 to 4. Okay, now let's just plug in the 4 because the 0 is going to give me a 0. So I'll just type it in one line then, since I only need one answer. 2 pi, that'll be 4 times 4 squared minus 2 sevenths times 4 raised to the 3.5. That's 7 halves. 172.34. Okay, just practicing a new technique today. Your assignment is going to be page 400, number 1, part C only, and then 3 through 7. That's 6 of them. Okay, ending there.